Hello everyone and welcome back. In this video I'm going to do a few problems on how to calculate the root mean squared velocity using the equation that was given. So here's a couple of problems. And they're pretty basic problems. It's just using the equation and being able to use that to solve problems. And so here got problem number one. We'll start with that. So problem number one is calculate the root mean squared velocity of oxygen molecules at 25 degrees Celsius. So you got to know the equation. So the equation is you have the root mean squared velocity. So again, U is the term or the symbol for velocity. Root mean squared is going to be equal to the square root of 3RT over molar mass. Okay, so if they give you everything, this is just a plug and chug problem. So they don't give you the molar mass, but they do give you the formula for oxygen. You should know that oxygen is a diatomic molecule, so you're going to multiply the molar mass of the atom oxygen by 2. That's going to give you 32, approximately 32. So we'll have 32 grams per mole. And remember, the thing to keep in mind is since we're doing energy, this is going to be in kilograms. So we need to convert that to kilograms first. So when we convert that to kilograms, you'll have 32 grams of oxygen over 1. Remember the equality. So remember, so if I'm relating grams is equal to kilograms, the way I do that is I always put the 1 with the prefix, and then the prefix multiplier for the prefix k goes here. So that's 10 to the third. And so I can use that as a conversion factor now. So 1 or 10 to the third grams of O2 on the bottom, and then 1 kilogram on top. So grams cancels out, and you get 0.032 kilograms of O2. So now I have the molar mass in kilograms. And the next thing I need to do is I need to make sure the temperature is in Kelvin. So I have 25 degrees Kelvin. So here we'll do 25 degrees Celsius. Sorry, I said Kelvin before, plus 273.15. And that's going to be equal to 298.15 Kelvin. So we're adding together, so we have to pay attention to decimal places. This has 0, this has 2, so I'm only allowed up to the 98. But I'm going to keep the 0.15 for the purpose of rounding, avoiding rounding errors. Okay. So now I have everything I need. I'm going to plug into the equation. So I have the square root of 3, and in this case we have the R value. So we need to make sure we have the R value correctly. So the R value that we're going to be using is going to be 8.314. So 8.134, and again, remember that's joules per mole Kelvin. Okay, and then we have T for temperature. So we're going to multiply by 298.15 Kelvin, all over the molar mass, which we calculated in kilograms. So 0.032 kilograms. Okay, joule. So this is why it's important to remember what a joule stands for. So if you remember, a joule is energy, right? And if you remember the kinetic energy, right? Kinetic energy is equal to 1/2 mass times the velocity squared. Mass unit is kilograms, and velocity is meters per second. So that's going to be meters squared per second squared. Okay, so this is why it's important to know that, because we got kilograms here. So kilograms is going to cancel out from the units in joules. So that's going to cancel out. We're going to be left with meters squared over centimeters squared. So that's going to cancel out, and we have meters squared over centimeters squared. Kelvin is going to cancel out. Oh yeah, and I forgot, can't forget moles. So this is molar mass, so can't forget the moles. And then the moles are going to cancel out because I have moles here and here. So the only thing left is meters squared over second squared. And so we're going to take the square root of that. And so the units are going to become meters per second. So, which is what we want, because we're looking for a velocity or speed, which is meters per second. Okay, so now all I need to do is put this into my trusty calculator. And so I get, so 3 times 8.134 times 298.15 divided by 0.032 equals, and I get a very large number. So that number is equal to, okay, so I need to take the square root of this. So I need to just take the square root first, and then that way I save board space. So we'll take the square root equals, okay, better. So I get 476.820, blah, 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 and that's going to be meters per second. And then I pay attention to sig figs. So here I have 2 sig figs. Here I have 4. The 3 is exact, and here I have 3. So I limit it to 2 sig figs. So I have my 4 and my 7. So I'm going to cut it off there. So I have 4. I have a 6 here. So I'm going to round the 7 to an 8, and then replace the 6 with a 0. And that's going to be meters per second. So that's going to be the speed, the average speed, the root mean square velocity of oxygen molecules at this temperature. Okay, so what about the next one? So this one we'll do a little bit more quickly because it's the same type of problem. Here it wants to calculate the root mean square velocity of xenon atoms at the same temperature. So same thing. So the root mean square velocity is equal to the square root of 3RT over the molar mass. And so again, we have the temperature. We already calculated the temperature here, so that's going to be the same, to 98.15 Kelvin. Here, the molar mass is going to be different. So we have xenon, so we'll look that up on our periodic table. So xenon is 131.29. So molar mass is equal to 131.29 grams per mole. Once again, I use my conversion factor to convert. I'm dividing by 1,000, so I'm going to do the same thing here. So it's going to be over 1, or let's just rewrite it. So I'll do it here. So 131.29 grams over 1 mole. Okay, so I should have had 1 mole here actually. 1 mole of oxygen. And then I'm going to do the 1 kilogram. 1 kilogram of oxygen over 10 to the 3 grams of oxygen. Grams cancel out. and then I end up with 0.13129 kilograms per mole. Okay, so there's my molar mass for argon or for xenon. I have my temperature, so now I just plug everything in once again. So it's going to be the square root. It's going to be 3 times R again, 8.134, and again, joules. But this time I'm going to replace joules with the kilograms. So kilograms times meters squared over seconds squared over, what else? Over moles Kelvin. Okay? And then that's going to be multiplied by the temperature, which is 298.15 Kelvin, divided by, and then the molar mass, which is 0.13129 kilograms per mole. And now, once again, kilograms cancels out. Moles are going to cancel out, and Kelvin cancels out. We're left with meters squared over seconds squared, and then that's going to be square rooted. So if we do our calculation again, we're going to get 3 times 8.134 times 298.15 divided by 0.13129 equals, and then we're going to take the square root of that. Oops, don't want to do that. Okay, and that's going to be equals, and then we get 235.4. So that's going to be 235.404 and that's going to be meters per second. And again, we're going to look at sig figs here. So for molar mass, we have 5 sig figs, we have 4 here, and we have 3 here. So in this case, we're going to have, let's see, 4 sig figs. So then we have 1, 2, 3, 4. We chop it off there. So that means we're going to have 2.35.4 meters per second for the velocity. Now, I just realized this would actually have 4 sig figs because when I did this, I estimated. So in actuality, this is probably, if I was being more exact, it would be 32.00 grams, or actually it would be, I want to say, 00, depending on the periodic table. It's going to be really close. So that's probably more like 4 sig figs. So this might actually be in 4 sig figs. So if you do 4 sig figs, it would be 477 because of the 8. So 76.8 sig figs because of the 2. We keep the 8. So meters per second. So just depends on how many sig figs you have. I hope that's clear. Again, these are very basic problems where you're just using the equation. So it's good to know the equation because you could use this for other problems as well. So I hope this was helpful. If you like this video, like the video, share the video, subscribe, hit the bell notification, subscribe to the video, make a comment in the comment section, let me know what you think, and if you want me to go over anything else. Thanks for joining me, and have a good day. See you next time.